Okay, we're in section 65 now, right? So let me just outline what we're doing over here. The intent of this is to prepare you to do the exercise number 65. Again, try to read through the contents, make some attempt to understand what you're reading, looking at the examples. Of course, we'll go through the examples at the whiteboard, but your real intent here is after going through the content examples to get busy with the exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra that date back to 1904. This document is being prepared for the Prison Mathematics Project, participants only. It will be published at a later date, though, and what I mean by that is, once I feel it's up to snuff, I'll publish it, all right? Now, if you're a teacher or student watching these videos and you're interested in getting a copy of it, email me, and I'll update you when it's going to be available. My name is Bannon. My email address is also Bannon, which is B as in boy, the @ symbol, NNON.US. And I'll do my best to answer if you have questions, all right? Certainly my intent is to get this thing published and at the hands of people who want to see these things over here. So, the bottom line over here is, you're looking at Wells's work, and he says, solutions of simultaneous equations by higher degree by factoring. It basically is what he's using the zero product rule. All right, so what I want to do is, I certainly, you can read through his examples if you like. As I do the problems, it might look different than what he does, but the intent is the same. So this one over here, I want to point out, I clearly see that they're writing these problems, at least initially, where I notice it's a product, it equals 0, and the second equation is also a product equals 0. So they're basically using the zero product rules. But this is a simultaneous equation. The solution to the first equation must be a solution to the second, so forth and so on. The second must be a solution to the first. So what they do is they notice that there's two factors in the first equation, and there's two factors in the second equation, which means there's going to be 4 combinations. And they write the combinations down as follows. So they're going to take the factor x minus y and then combine it with these two factors over here. Let me point out where that is. That's case A and case B. Then what do? Let me get my eraser out. There's going to be 4 cases, by the way. They take this guy and combine it with these two factors. There's going to be 4 combinations, by the way. Let's point out where that is. And that would be x plus 2y minus 1. They combine it with the x plus y, that's first factor, second equation. Then they take this x plus 2y minus 1 and combine it with the second factor, which is x minus 3y plus 2. All right? Let me get my eraser out, and there's 4 things for me to solve. All right, 4 different systems for me to solve. Now, someone says, I want to try to do it differently. We're not opposed to it. What we're opposed to is if you don't try. That's what we're opposed to. We want you to try. Now, the first equation, case A, really simple to do. Just add these together. What do you get? 2x equals 0, or x equals 0. And then plug it into the first equation, and you get y is equal to 0. So I got 1 point of intersection. You can check this by looking at the original system and plugging it in. And if you did that, the first equation clearly would be 0. That does equal 0. And the second equation, if you plug it in, clearly get to 0. So it checks out. It checks out beautifully. Let's do the next one, a little more complicated, and I'm going to write it a little differently. We'll check it too. And what do you get over here? X minus y equals 0. And then you get x minus 3y, right? Equals minus 2. I'm going to multiply the second equation by minus 1. And what do you get? X minus y equals 0. Then you get minus x plus 3y is equal to minus 2. Add them together. You get 2y. We'll check it too, by the way. Minus 2. Did I make a mistake there? Oh, I'm sorry. This is plus 2. Because when you multiply by minus 1, you get plus 2. What's y going to equal to? 1. All right? So if y is 1, looking at this thing, x would have to be 1. So I know my solution 1, 1. I'm going to check it. I'm going to go up here. Clearly, the first equation, whoops, sorry about that. The first equation would be 0 equals 0 if x and y are equal to 1. The second equation, a little more difficult. It's going to be 2. 1 plus 1 is 2, by the way. Then you get 1 minus 3 plus 2. Well, lo and behold, the second factor is equal to 0. So this also satisfies the system. All right, and the system has 2 equations that are completely factored. Let's look at this one over here. And I'm going to write down a little differently. I like to write them in a proper order, which can be x and a y equals a number. And this will be x plus y is equal to a number. The number happens to be 0, by the way. I'm going to multiply the second equation by minus 1. It's pretty simple to do. You get x plus 2y is equal to 1. And you get minus x minus y is equal to 0. Add it together, what do you get? You would get y is equal to 1. Well, that was easy. And then I'm going to look over here. It's easy for me to do that. If y is equal to 1, x would be equal to minus 1. And that's certainly what they have listed over there. Let's go back up here. I'm going to check it. I always say if I make a mistake, I'll discover it by checking. And what did we say? Let's make sure we said minus 1, 1, right? Oops. Let's plug in the first equation. What do you get? Minus 2. That's not very good. And then what do you get? You get minus 1 plus 2 minus 1. And this is encouraging because this factor does indeed equal 0. And 0 times minus 2 is 0. Second equation, really simple. You get minus 1 plus 1, which is 0. There's no need to look at the second factor. The product would be equal to 0. So that works. Let's go to the next one. And we'll look at the picture later. This one's probably the most difficult one to do. And I'll write this down in the order I like, which is x plus 2y is equal to 1. And you're going to get x minus 3y is equal to minus 2. I can multiply the second equation by minus 1. You can get x plus 2y is equal to 1 minus x plus 3y is equal to 2. Add it together. What do you get? You get 5y equals 3, or y would equal 3/5. Right? Much more difficult, by the way. Someone says, where are you going to plug it in now? I don't know. Maybe here. And what do you get? X plus, let's see, 2 times 3/5 is 6/5, right? And 1 in terms of fifths is 5/5. Well, this pin's pretty easy. X is going to minus 1/5. All right, let's see if we got that. Yep, right here. All right, I want to go back to the original system. This is more difficult to check. Whoops, sorry about that. I'm going to check it. I know it's tough. Some people say, I don't want to check. Mistakes happen, that's why we check. So what do you get? First equation. Minus 1/5 minus 6/5 is minus 7/5. That's not encouraging. I want a 0. What do you get in the next line? Well, you get, next factor, Minus 1/5, 12/5. And then you're going to get, what's minus 1 in terms of this? It's going to be, let's see if I did a mistake here. X 12/5. First of all, did I copy it right? 12/5. Let's see if I got it right. Oh, I'm sorry, it's 3/5. The reason I said that, it wasn't making any sense. And this happens to me sometimes. I got to erase this. It wasn't working out. All right, so let's go back. What do you get over here? You get minus, let's see, minus 1/5, minus 3/5, minus 4/5. Not encouraging. What's x? Minus 1/5. Let's see, 2 times y is 6/5. And then 1 is going to be 5/5. This is encouraging news. Why is that? This turns out to be 0. Let's go to the next one. Minus 1/5 plus 3/5 is 2/5. Not encouraging. I want a 0. Let's go to the next one. Minus 1/5. Whoops. Going crazy there. Then minus 9/5. Again, I'm hoping for a 0. And that would be 10/5. What do you get? Well, minus 1 minus 9 is minus 10/5. Minus 10/5 plus 10/5 is 0. This factor is 0. Of course, it equals 0. So these are all good solutions over here. All right, now someone says, how do you graph that? It's not a bad looking graph, by the way. It's pretty easy to do. It's going to be a series of lines. Let me get my eraser out. And I want to point out, I'm going to do one line at a time. Now, someone says, do I need to graph it? No. And Wells doesn't graph it either, by the way. So someone says, why doesn't Wells graph it? I think back then, textbooks were, it was really like an industry of people that would do certain things, typesetting, graphing, things like that. But right now, certainly the burden has become the burden of the author now. He's the guy typesetting the books, all right, especially in mathematics, by the way. But I want to point out one of the equations, which would be this over here, where x minus y is equal to 0. Now, what does that translate to? X equals y. What I want to do is I want to look at the graph, and I want to show you where the graph x equals y is. It's right here. All right, I'm going to do another graph, and I'm going to do an easy one. I'm going to do this one over here. This is a factor that must be equal to 0. So x plus y is equal to 0. This is going to be a graph of y equals minus x. Let me go back to the picture. I'm going to see if I can see that. And I'm seeing that right here. And I'll write this down for you. This would be y equals minus x. All right, the other ones are more difficult. I know that. And let's put that down for you. I'm going to do this one now. And this factor must also be equal to 0, which means x plus 2y minus 1 equals 0. I'm going to, maybe write this a little bit differently. I can write it as 2y equals, let's see what you get over there. You would get 1 minus x. Well, that's not so bad. All right, let's talk about this one over here. And I want to point out, if I were graphing this guy, and I'm new at it, right? So I'll just put this over here, x and y. I'm going to say if x is 1, what would you get for y? 0. All right, I'm hoping you're seeing that point right here. Let me go for another point. And someone says, what point would you choose? I don't know, probably minus 1. And why is that? It's easy for me. 1 minus a minus 1 is 2, and 2 divided by 2 is 1. So I get this point over here. So I see my line now. And that's this line over here. All right, let's do the last one. I know it's tough. I'm going to do one at a time. I'm going to do this guy here. And what's this going to be? X minus 3y plus 2 is equal to 0. So it's going to be x plus 2 is equal to 3y, or y is equal to x plus 2 over 3. Well, I'm going to graph it out by putting some points down. X and y. I would say minus 2 is the easiest for me. What do you get for y? 0. Right there. What's another really easy point for me? 1. Why is that? 1 plus 2 is 3, and 3 divided by 3 is 1. That point's right over there. So now I got this line. Now I realize for a lot of students saying, that's just, I'm told, excuse me, all those lines you got drawn over there. Well, you're looking at the lines, and I want to just go through the points of intersections that we found. Right? And let's try not to be too confused. So I got the 0, 0. I'm going to do one at a time for you. I got 1, 1. Let's do that. A visualization is nice if you can use it. And let's see what else I have over here. I got to look at it, right? So I got the, let's see, 0, 0, 1, 1, minus 1, 1. That was pretty easy. And I got another point, right? Right here. This is a tough one, though, isn't it? And looking at it, I know it's fraction in both directions. The x is negative. Oh, right here. Look at that. It's minus 1/5, comma 3/5. All right, let me blow this up for you. And I want to point out what I mean by that. If you look at the x-coordinate, clearly minus 1/5. If you look at the y-coordinate, it's about 3/5 of the way up. I know it's hard to read that, but it can be done. All right? That's not bad. Let's go to the next one. And, kind of looking at it, I kind of like what Wells does, and I want to continue with it. So what I'm going to do, I'm going to factor. What's top equation going to be factored to? Let's write this down. It factors to what? X and x equal 0. And what do you get there? I'm going to say 2y and y, right? And let's hope this works out. And I'm going to say plus 2y minus xy. And what do you get in bottom? 2x It's a linear problem, by the way, in the bottom. So I'll just put a factor symbol on it. But I still want it to be equal to 0. So what I'm going to claim over here, there's going to be 2 separate cases. And why is that? There's 2 factors on top and 1 factor on bottom, which is going to give you only 2 cases to look for. All right, 2 separate cases. Remember, a solution to a system equation must satisfy all equations. All right? Now, granted, you can graph it out if you want. They're pretty easy to do. There'd be 3 lines to graph. All right? And we're looking for the points of intersection for those 3 lines. Right? Whatever solution we find must satisfy all equations, though. So I'm going to put the cases down for you, and they're pretty easy. One of the cases would be x minus y. Let me point out what I mean by that. This factor combined with this one. And the other one's going to be this factor combined with this one over here. I'm going to go show you where that's written down for you. And I got this one, the case A. There's only going to be 2 cases, by the way. And the other one's going to be x plus 2y, case B. I'm going to solve these guys over here. I like to write things in the order I like, which is x, y, equal number, 2x plus 3y is equal to minus 6. I'm going to multiply the top equation by 3. And what would you get? You would get 3x plus 3y, and 3 times 0 is 0. That's easy. 2x plus, I'm sorry, I made a mistake. I got to get my eraser out. So 2x minus 3y equals 0, and the bottom is 2x plus 3y is equal to minus 6. Add them together. What do you get? 5x equals minus 6, or x equals minus 6/5. How do you get the y? Plug it in here. Let me write that down for you. Minus 6/5 minus y equals 0. And that's pretty simple. What's y going to be equal to? Y would equal to minus 6/5. That's written over here. Let's do the next one. And again, the way I like to write them down is put them in order. And what do you get over here? X plus 2y is equal to 0. 2x plus 3y is equal to minus 6. I'm going to multiply the top equation by minus 2. And what would you get there? Let's write this down. You get minus 2x minus 4y is equal to 0. And then you get 2x plus 3y is equal to minus 6. I got to add things together, right? So what do you get? Minus y equals minus 6. Y is 6. Now, if I'm going to do that, I'll pick this equation here, and what would you get? X plus 12 equals 0, so x has to be minus 12. That's written over here. Okay, let me talk about graphing it now. And granted, I'm not saying it's easy to graph. I'm just saying it's worthwhile. It's really worthwhile. And there's actually 3 lines I have to graph. So I want to go through the 3 lines, and certainly when you graph, you could also be confused by what you're seeing. So I'm going to point over here that, x minus y equals 0 is a line. And what's that line going to be? X equals y. I'm going to make sure you understand that that's a line, and that line is right here. And this is the line x equals y. I'm going to graph another line. I'm kind of, picking them off easily. I just did this one. Now I want to do this one because I think it's easy to do. And what's that going to be? Well, that's going to be x equals 2y. I'm sorry, x plus 2y equals 0. And I'm going to say, solving for y, you don't have to, by the way, but I like to. That would be 2y equals minus x, or y equals minus 1/2 of an x. Now, granted, it's more of a challenge, but I want to point out, you could take points. These are lines, by the way. You get 0, 0. That's a good point. Another good point to choose would be, let's see. I got to be careful here. So I'm going to say x to be 2. And the y would be minus 1. So I'm going to plot those points down for you. There's a point here, 0, 0, and 2 minus 1 right over here. I see that line now. And yeah, it's nice having a good picture because you can just trace right over it. I got to do another line, by the way. And someone says, well, there's only one line left. Why don't you just write it down? I want to make sure I got the right line. And what do you get? You get 2x plus 3y equals minus 6. I'm not going to bother solving that for x or y, but I'll put a table down. And the reason for that is I think it's going to be easy. So if I chose x to be 0, you would get minus 2 for y. That was easy. If you chose y to be 0, you would get minus 3 for x. Well, I'm definitely convinced that's the right line. Okay, I found 2 points of intersection. I want to point out what those points are. This point here, which is minus 12, 6. I hope you realize that you could trace down there, see the minus 12, trace over here, and see the 6. I'm going to be honest with you, that's not the easiest thing to do, by the way, because it may not have been that number, but I did solve it. I know that. I checked it. And the other one's going to be minus 6/5, minus 6/5, which is this point right over here. I'll write that down for you. And again, if you were to blow that up, I'll be honest with you, it looks about minus 6/5. All right? I got to be honest with you, looking at it, this sure does look like another point of intersection. It's where the lines are touching each other. And what's that point? 0, 0. Unfortunately, it's not a solution to the system. And let me tell you why. Let's go back. The reason it's not a solution to the system, although it may be a solution to this equation here, 0, 0 works there, it is not a solution over here. Remember, solutions must be solutions to all equations in the system, and it's not. All right, so number 2 is done. I'm going to go number 3. And number 3 looks, I'll be honest with you, it's not factored, and it's not even equal to 0. So I'm going to say it's a bit tricky. I understand that some students may say they want to do it differently, and I'm not suggesting you can't do it differently. But what I want to do is I want to see if I can get at least a factor out of the problem. So I'm going to start to do what I think you should do when you get stuck. So I think a lot of students would get stuck on this problem. They would get stuck. So you look at the key, and this is not a bad thing to be doing. You're studying, so when you get to another problem like this, you might use the same trick twice. So my claim is people get stuck on this. All right? So what I'm going to say, I'm doing a trick over here, and I say it's a bit tricky. All right? And what I'm going to do is I'm going to multiply both sides by a number to get rid of that term on the right side if I can. All right? So what would I do? When I say get rid of it, make it the same, I should say, not get rid of. So what would I multiply the top equation by? 2. Because the least LCM between 7 and 2 is 14. So I'm going to multiply the top by 2. Whoops, sorry about that. I'll multiply the top by 2 and the bottom by 7. And let's see what happens. And again, this may be a dead end as well. You're going to take a lot of dead ends in life, but that's fine. When you get to a dead end, back out. This is going to be 6x squared plus 2y squared is equal to 14x. What do you get the next one? 7xy plus 7y squared is equal to 14x. All right? Now, someone says, I still don't know what to do with the problem. And this is going to happen. A lot of times what you're doing is you're trying to learn from other people doing the work. All right? So I'm going to say subtracting the second equation from the first. This is the second. This is the first. So if I subtract, I will get an elimination. Let's write this down now. What are you going to get? Let's write this over here. So I'm taking the second equation from the first. So let's see what you get. You're going to get 6x squared. Let's see, minus 7xy. Let's see, 2y squared minus 7y squared is minus 5y squared is equal to 0. By the way, this could be a complete and utter dead end. What am I hoping for? A factorization. I'm really hoping for a factorization. So what am I going to do? I'm going to see if I can factor it. And let's write this down, because I'm looking for that zero product rule, by the way. So I'm going to say 3x and 2x. And I'm going to say 5 would be 5 and 1, right? I think I see it. Maybe not, though. Y and y, because I have to y squared, right? And what do you get there? I'm going to say plus and minus. And what do you get there? You get 3x times 2x, 6x squared. Then you get 3xy minus 10xy minus 7xy. Worked beautifully. All right? So, certainly when you're looking through this, you're studying what other people have done. Right? Again, remember what we did, bit tricky. First we multiplied the top equation by 2, second equation by 7. Then we did a little subtraction. We got this over here. And we're studying. And then we factored. We got this over here. I want to point out it's right over here. We did that. All right? So I'm going to say, use the zero product rule. And what would that equal? I'll write this down for you. And again, it could be another dead end you're taking. These are not, at least these are not dead ends, but you're still not there. Right? So I'm going to say 2x plus y equals 0. And what does that mean? Y would equal minus 2x. Again, for this thing to be 0, 2x plus y must be equal to 0. So, y equals minus 2x, I could say. Does that help me? Not really, but maybe if I substitute it, it might help me. Who knows? And what's the other one going to be? Well, the other one's going to be, I'll write it down for you. It's when 3x minus 5y is equal to 0. And let's solve that for y2, okay? All right, let's see if we can do that. So 3x would equal 5y. So that means y would be equal to what? Y would be equal to what? 3/5 of an x, right? All right? So what do you do now? I'm going to try substitution now. And again, it might seem like a long way to nowhere, and it could be. You could be going down another road that leads you to a dead end, but at least you're moving. And that's important. At least you're moving. So what I want to do is I want to go back. I don't know. I'm going to take this equation here because I think it's the easiest one to look at. And I'm hoping things are going to work out pretty nice. So what is that going to be? xy plus y squared equals 2x. And I'm going to start making substitutions now. And what substitutions would I make? And let's do this one first. So it's going to be x, and y is minus 2x, right? Plus minus 2x, because that's what y is, squared, equals 2x. What do you go here? Minus 2x squared plus 4x squared is equal to 2x. 2x squared equals 2x. 2x squared minus 2x equals 0. I'm still using that zero product rule, by the way. I'll divide both sides by 2. You get x squared minus x equals 0. And what do you get? X minus 1 equals 0. All right? We met this milestone over here. What do I know about x now? X could be 1 or x could be 0. If x is 1, right, I want to point out we're using this over here. I could figure out the y, right? That's minus 2, isn't it? Whoops, sorry about that. And if x is 0, what would the y be? Y would be 0. We can check these later, by the way. All right, let's go to the next one. Next one a little more complicated, like that fraction, right? And you say, I can't remember. So I'm looking at this guy over here now. And again, I want to go back. I know it's tough. I'm still going to use this guy over here because I think it's the easiest one to use. And what do you get? You get x times the y. Well, the y is 3/5 of an x. Plus the y squared. I'm doing this one. That would be 9x squared over 25 equals 2x. Let's keep going through this. 3x squared over 5 plus 9x squared over 25 is equal to 2x. I'm going to multiply both sides by 25. 15x squared plus 9x squared equals 50x. I got to keep plowing through it. And what do you get there? You're going to get 24x squared equals 50x. 24x squared minus 50x equals 0. I'm going to divide by 2. You get 12x squared minus 25x equals 0. I'm going to factor an x out. And what do you get? Let's take a look. You would get 12x minus 25 equals 0. What do I know about x? X could be 0, or x could be 25 twelfths. All right? I want to make sure you know we got these milestones over here. I got this over here. Now, what's the y going to be equal to? Remember, this is what the y is equal to. We just did that. Y would be 0 there. And what's the other one going to be? Y equals, well, I got to be careful. It's 3/5 times 25 twelfths. This is 4. This is 5. 5 quarters. Let's see. We'll check them too, though. I got this one. I got this one. I got this one. And I got this one. Okay. Looking over Wells's text, he does make errors. I think makes errors because he really writes some tough problems. We have technology, though. So what I'm going to claim over here is that I actually graphed the system for you. I want to go back over and we'll look at the graph of the system. And someone says, this is a really tough system, but I want to claim that we are definitely looking at 3 points of intersection. Here, here, and here. What's this point over there? 0, 0. What's this point over here? Well, I got to be careful about that. But I got to be honest with you, it's not that bad. It looks a little bit better than 2, so it's actually 25 twelfths. Now, someone says, could you have read that from the graph? No, I'm looking at this. What's the y-coordinate? It's a little bit bigger than 1, but I couldn't read it from the graph. It's 5 quarters. What's this point over here? Well, it's going to be 1 minus 2. And I got to be honest with you, although you think you can read this from the graph, you may not be able to read that from the graph. All right, this one I definitely couldn't read from the graph, by the way. But I agree with it. I agree with it. Now, let's talk about what these structures are. And I want to point out, looking at the structures, there's 2 of these things over here. I'm sorry, I should look at these structures. I'm sorry. All right. So I'm going to point out this one over here. The top one is the ellipse. This thing over here. Maybe I shouldn't call it an ellipse at this point. Maybe I should just call it an oval. That's the first equation. I know I didn't do a very good job over there. And this guy over here, it's a tough graph, this one. All right, that's a really tough graph, by the way. All right, so let's go to the next one. Next one also, I am honest that you're going to get stuck. And part of getting stuck is you want to study the examples that are being provided for you. And this will be the last one in the examples. And, kind of looking at it, if you were looking at it, what would you do? There are many things you could do. But the bottom line, I'm trying to use this 0 product rule if I can. And one thing you could do is, maybe, I ain't going to say it's tricky. Maybe you could just simply subtract the 2 and see what happens. And what would you get? X squared. Remember, trying leads to dead ends a lot. But if you're not trying, there are no dead ends. But dead end, it's better to be at a dead end than nowhere, all right? Or stuck. Oh, by the way, if you're in a dead end, walk out of it. So x squared minus y squared, then you're going to get, let's see, what would you get over there? I guess you'd get 2x, right? And then y minus 3y is minus 2y. Well, that's a partial success, I guess. Let me get this and see if I can do it. So let's take a look at this. You get x squared. Oh, you know what I'm going to do? I'm going to factor it right as it stands. Let me put this down for you. And again, I'm not saying it's not a dead end. I'm just saying that if you're not moving, that's not good. Now, some people are paralyzed. They can't move because they don't know where to go. All I can say is squirm your way out. All right. Okay, I realize what some students want to do. They want to divide both sides by x minus y. I'm not opposed to it, but I don't think it's a good idea unless you're really thinking about that. Because if you're dividing by 0, you lose a solution. All right, I'm going to write this over here. And what do you get there? X minus y factors out. And you're left off at x plus y minus 2 equals 0. I want to point out that is a milestone for me. So I'm gonna outline where that milestone is. Since we're looking at this over here. It's right over here. Now someone says, why is that a milestone? I have a 0 product now, right? And that's a really important fact that you have. But it's still going to require a substitution. Let me point out what I mean with that. So what are we looking at? We're looking at x minus y equals 0. The substitution would be x equals y. And the other one, it's more difficult, but I write it down for you. It's x plus y minus 2 equals 0. And let me write this down as, let me see how I'm going to write that down. I'm going to write it as y equals. And what's that going to be? 2 minus x, right? What are you going to do? Back substitute. It's tough. So let's take a look. And I'm going to look up here. And I'm wondering, what equation would be the easiest one to use there? Maybe the first equation. X squared equals x plus y. I'm just using the first equation. X squared equals x plus y. Let's do this one first. What do you get? Let's write this down. X squared equals x plus x. Let's keep going. X squared equals 2x. Let's keep going. X squared minus 2x equals 0. Let's keep going. What do you get? X minus 2 equals 0. So what do you get for a solution over here? X equals 0 and x equals 2. If x equals 0, I'm doing this over here. What do you get? Y equals 0. That was easy. If x equals 2, what do you get? Y would equal to 2. So we see those two solutions right over here. We're done with that. Now what I want to do is I want to go to this one over here. Let's write it down. And I'm still using this equation here. Still going to use it. It's going to be tougher. That's why I saved it for last. So you get x squared equals x. And what's y? Well, it's 2 minus x, isn't it? Well, it doesn't look too bad. What do you get? X squared equals 2. So let's write this down. What would x equal? Plus or minus the root of 2. Let's write this down. Root 2, or it could be minus root 2. What would y equal? I got to be real careful here. This is what the y is. So what do you get? 2 minus root 2. Over here, what do you get for y? By the way, that's a solution. We'll look at it later. The other one's going to be y equals 2 minus root 2, which is 2 plus root 2. I'm seeing those answers here. Root 2, 2 minus root 2, minus root 2, and 2 plus root 2. All right, so I'm going to say that, I want to look at the graph of the system. I know it's tough, but I have a machine that does the graphing for me. So what do I see? I see 2 graphs, and I see 4 points of intersection. And again, it's important you start looking at the pictures we provide to you. I want to identify these points for you, though, and one at a time. This one's really easy for you to identify. That point would be 0, 0. This point's really easy to identify. It's 2, 2. This might be more of a challenge for you. But I hope you realize that root 2 is a positive number. This is root 2. Comma, 2 minus root 2. This point's also easy to identify looking at the picture. It's minus root 2, comma, 2 plus root 2. All right, please look at the pictures. All right, again, I know it's a tough section. I like Wells's work just for that one reason alone. He gives good problems, all right? As opposed to textbooks nowadays, I've been teaching for almost, in my fourth decade of teaching, I can tell you the problems are really, they're almost brainless at this point. But anyway, not all of them, by the way. There's some really good algebra problems out there still. But most textbooks are really just a nonstop feeding of very simplistic problems, all right? So what are we doing over here? Exercises. That's what you need to do. And the exercises are going to be, for the most part, not too bad. Looking at number one, you got two factors here. This thing needs to be written as a product to be 0, so you subtract 23 from both sides. And the bottom line is you got some issues over here to deal with, all right? So you write them down. And what I mean by that, there's going to be two separate cases. And why is that? Look at the top, 2 there, 1 there, and you write down, you solve the system. You get 2 different points of intersection. I put the graph down for you, and there are a bunch of lines, by the way. This one's a little straightforward. 2 factors there, 2 factors there. 2 times 2 is 4. You'll have 4 cases. Look at all those lines. This one over here, my recommendation is to try to factor it. Top, you'd have 2 factors. Bottom, 1 factor. 2 cases. Again, we probably guessed for a reason. Again, my suspicion, factoring, 2 cases. Factoring, 2 cases. All right, more of a challenge. No doubt about it. More of a challenge. And looking at it, if I were doing that, I'd probably do substitution. All right? I'd probably do substitution. I give pictures for that too, by the way. 7. By the way, these took me a lot of time to do. It isn't like I look at these and think, like, gee whiz, that's simple. No, it took me time. It'll take you time too to get through these. Why do we put answers down here? Hopefully you're going to look at that if you need to. Why put graphs down? Hopefully you're going to look at it if you need to. Let's see, 7. Again, they're definitely more challenging. There's no doubt about it. More challenging. Wow, that one looks really challenging. Challenging. A challenge. Well, he gets a lot of problems, doesn't he? And that's good too. It's not just, these are really challenging. And why? Basically, you have, parameters in the problem that make it far more difficult to deal with. For one thing, they're almost impossible to visualize, at least for me anyway. Anyway, I go through that. It's tough. The work's down there, but it's tough. And then you get to this related SAGE code. What's SAGE? It's a computer algebra system, or a CAS. It's open source software. Go to this website. You can download it. Web-based application. Type in some code. My goal here is not to so much teach a SAGE. It's to go through what Wells is doing in his topics. We think you should do that. If you see any errors, though, please reach out to me. My name is Bannon. My email address is Bannon, which is B as in boy, the @ symbol, NNON.US. And I really do appreciate when people reach out to me. Thank you.